Welcome and thank you for joining. Today we are going to take three plain CSV files of sales orders and turn them into a working analytical solution inside Microsoft Fabric using Apache Spark and a notebook. No infrastructure setup, no clusters to configure, nothing to install. If you have never written a line of PySpark, you are in the right place. If you already write Python, you will still pick up the Fabric specific parts, one lake, the lakehouse, delta tables, and the built-in chart view. Everything I run today is available as a free Microsoft Learn Lab, so you can repeat it afterwards at your own pace. I will drop the link in the chart now. Okay. One request before we start. Tell me in the chart where you are joining from and which tool you use most today, Excel, Power BI, or something else. I will read those out as we go. I have forgotten to share my screen. No, I hope is everything is okay. Here is the whole session on one picture. On the left, three files of orders, sales orders, one per year from 2019 to 2021. They go into a lakehouse, which is simply a place in Fabric that holds both files and tables in the same storage. In the middle sits a notebook. That's where we write code, run it, and see the result immediately underneath. Spark is the engine that does the work, and it runs behind the notebook without us managing it. On the right, three outputs. Parquet files that are far more efficient than CSV. A delta table that we can query with ordinary SQL, and charts, first with the built-in chart view and then with the Python libraries. The one idea I want you to hold on to is this. In a lakehouse, you do not have to choose between files and tables. You start with files and you promote the parts that deserve structure into tables. This is the whole point of the word lakehouse. So, okay, let me close this one and let me open one tab. And I'm typing at powerbi.com or app.fabric.microsoft.com to access into my Fabric. So this is Fabric homepage. If you have used Power BI in the browser, this will feel familiar because it's the same platform with more workloads on it. Let's wait for a while. I'm refreshing the website and selecting Workspace. A workspace is Let me cancel. A workspace is a container. Everything we build today lives inside one. And when we are finished, we delete the workspace and everything goes with it. That's also the cleanest way to keep your trial capacity tight, as we are using our trial capacity. And we are 38 days left. Okay, two things to note here. First, give it name you will recognize later. Second, and this is the one that catches people out. Open the advanced section while we are creating a warehouse, actually a workspace, and choose a licensing mode that includes Fabric capacity. This is trial, premium, or Fabric. If you skip this, the notebook will not run because there is no capacity behind it. Let's click one more time on workspaces, new workspace, and yes, let me give DP sales orders WS. For description, I'm entering lab purpose only. And from advanced part, I'm selecting Fabric trial and apply. Okay. So empty workspace, blank canvas. So let us give it somewhere to put data. New item, and then lakehouse under store data. So this can take up a minute to provision, which gives me a moment to explain what we are actually creating. Sales orders, lakehouse. Okay, a lakehouse gives you two things at once. A files area, which behaves like a folder, structure where you can drop anything, and the tables area. Let's create, and which holds delta tables that behave like database tables. Both live in one lake, which is the single storage layer underneath all of Fabric. One copy of the data, many engines able to read it. And also just pay attention, we checked lakehouse schemas option. We pointed this one. So now on the left is Explorer, right? With tables and at the top and files below. Right now, both are empty. Let's fill in the files side. I downloaded and extracted this folder before we started. And the link is the chart in the chat if you want it. So let me share the link once again, where you can find all the necessary codes that we are writing today. Sorry. Right. So let me type the link. You can download all the necessary files. Okay. So that's done. There are three files: 2019, 2020, and 2021. Let me, by the way, open that one, orders. So these are the files that about which I'm talking about. Okay, so each one is a sales order lines, and I want you to note something important. There is no header row. The first line is all the data. That detail will bite us in about 10 minutes, and I'm going to let it. Let's click on ellipsis in front of files and say upload, upload folder. And let me select that folder. Actually, when I downloaded, it was in zip format and I extracted from zip format and upload. Upload. This is the simplest ingestion path in Fabric, and it's live for a demo. Production, you would use a pipeline, a shortcut to existing storage or data flow agent too, and none of these change anything about the code we write afterwards. Let me close and select files. And here, three files uploaded, right? Note they're still just files. Nothing has been parsed. No schema has been applied. Nothing has been validated. That's deliberate. And it's the difference between a lake and a warehouse. Let's open a notebook, and new notebook. So because I launched it from inside the lakehouse, the notebook is already attached to it, which means my file paths can be short and relative. That saves a lot of pain later. So the names of notebooks arrive like notebook one, and for further notebooks, it can arrive like notebook two, three, four, five, six, seven, so forth. So let's rename it straight away. And 6 months from now, notebook 1 through notebook 14 will tell you nothing. So I'm going to click here, select notebook 1, and say sales order exploration. Enter. And this is the name of my notebook. Then I'm going to, while I'm here, I'm clicking on M arrow, button. And then I'm click on pencil for edit. And I'm typing this one. It's enough to click outside the cell just to render it, right? And the notebook is a sequence of cells. Some hold code, some hold text. This one is text line. And I would encourage you to use these far more than you think you need to. A notebook without commentary is a script with worse ergonomics. A notebook with commentary is documentation that runs. So, what we are going to do, okay? I'm coming to my files, right? And here, ellipsis and upload. Actually, let me, yeah, in front of orders, upload, upload files, right? You can see it. So what we are going to do, If I select order, I can see all the necessary, files that I have uploaded within the folder. So in front of 2019, I'm clicking on ellipsis, load data, and I select Spark. Rather than typing anything, I'm going to let Fabric write the first cell for me. Load data, Spark, and that's it. It is. So data frame equals Spark dot read dot format. This is the CSV format. Header is true. Load. This is the pass, right? And display. Let's run it. Three things in one line. We are reading the format is CSV and path is relative to the lakehouse, which for now you can think of as a table held in memory across the cluster. And display is a fabric function that renders it nicely rather than printing raw text. First run of the session. So Park now starts a session for us. And this takes a few seconds, sometimes longer. Every run after this one in the same session will be much faster. So please do not judge Spark on this first number. Now look carefully at the top row. All column headers are S04 3701. Actually 01. This O letter. And a date, name, customer name. And that's not a header. That's our first order. We have lost a row of data and gained nine nonsense column names. And this is the single most common mistakes when reading raw files. And Fabric did not do anything wrong. Guest header equals true because that's the usual case. Our files are the exception. So I'm going to make some addition in this code. So instead of true, I'm going to type headers are false. And I'm going to run once again. Let's wait for output. Okay. Now we see different column names like CO, C1, C2, C3, 4, 5, 6, so on and so forth. Okay. This is better. The data is all three there now. But look at the names like C0, C1, C2, C stands for column. Correct and useless. Nobody wants to write a report against underscore C7, column 7. So we do the thing that separates a demo from a solution. We tell Spark exactly what the data is, rather than hoping it guesses. We define a schema. So let's replace or let's type new set of commands, code, and let's run it. Here we have code. I'm clicking on code and pasting my code, right? Okay. So let's read this top to bottom. So here we import the Spark SQL types. We describe 9 fields in the order they appear in the file, each with a name and data type. Sales order number, string type, sales order line number, integer type, unit price, float type, text float type, quantity, integer type. Then we pass that schema into the RED instead of relying on inference, Spark RED format. So let's run it. And let's wait output. So here, order date, for example, okay. So what we can tell about this one, we can say that two benefits. And the second one matters more than people expect. I mean, meaningful names, obviously, but also when you supply a schema, Spark does not have to scan the file to work out the types. On three small files, that saves you nothing. On 3,000 large ones, it saves you a great deal. And not order date is a real date. And a unit price just is a real float. If you leave everything as strings, every downstream calculation becomes a conversion. And every conversion is a place to be wrong. Let's make some changes here. So instead of 2019, I'm going to delete it and type multiplication star. And now the part that makes people stop, one character, a star. That's the entire change. And we have gone from 1 year of data to all three. So let's run. And thanking to this, Spark treats a folder of files that share a shape as a single logical dataset. And it does not matter whether that's three files or they are 1,000. And it does not matter whether you add 2022 next January. The code does not change. If you have ever maintained a workbook with one sheet per year and formulas stitching them together, this is the moment that pays for the whole session. The preview only shows a slice of the rows, right? For example, 2021. And so do not worry if you cannot see all 3 years in the window. We'll prove they are there in a minute when we count them. Let's add one more code. Hover over codes and run. Two numbers on screen, the first number and the second number. The first is how many rows we have. 32, 7, 18. And the second is how many are unique. 12, 4, 27. The gap between them is your repeat customers, and it's usually the first interesting fact in any sales dataset. One point is of principle. Customers is a new data frame. We did not modify DataFrame. Transformations in Spark never change the original. They return a new one. If you come from Excel, this is the opposite of editing a range in place. And it's what makes the whole thing safe to run in parallel. The same selection can be written more conventionally as df for example, dot select with the column names. And in real code, that's the form you will see most often. Okay. So I'm talking about this one. So let me type one line of code. So I'm going to make some modification actually here in this code. So here for customers, for this data frame, I'm going to add something like df data frame.select between parentheses, customer name, email, where item equals to a specific product. So let me change this one. Okay, let me type it once again. Yeah. So here we can see select customer name email where item equals to this product, and let's run it. And now we have two operations. Select gives us two columns and where filters the rows down to the people who bought one specific product. So this one, bike score 250, rate 52. And the output of the first becomes the input of the second, and you can keep changing as long as it stays readable. So for anyone with a SQL background, you have just written select and where. Same idea, different punctuation. Let's add a code cell and run it. So it's going to group by item. Sum what remains. Because we selected only item and quantity, the only numeric column left to sum is quantity, which is exactly what we wanted. Be careful what with that pattern though. If you leave extra numeric columns in, Spark will happily sum those too. Okay. And if you leave, I mean, let's add one more code cell and run it. New code. I'm pasting my code and say run. So let's read the middle line as a sentence. Yearly sales, df.select year, column order date, alias, year, group by year, and count order by year. So this takes the year out of the order date, call it year, group by it, count the rows, then sort. 5 operations, one line, and it reads left to right in the order it happens. And there is the proof I promised. 3 years, three counts, 2019, 2020, 2021. And the wildcard did what it claimed. If you remember, instead of 2019, we replaced it with star. wildcard. That import at the top gives you the Spark SQL function library, and it's worth an hour of your time on its own. Anything you would reach for in SQL, yeah, months concat when route is in there. Let's add one more code line, and then let's paste our code and run it. Three transformations in one cell. First, we drive year and months from the order date because almost every report you will ever build wants to slice by those year and months. Second, we split columns we want. We want them, which also quietly drops customer name now that we have split it. First name and I think, yes, last name. Third, and here also, um, get item 0 and is the first element because Python counts from 0. So I'm talking about this one. And third, we list the columns we want in the order we want them, which also quietly drops customer name that we have split it. Actually, I repeat it for 2 times. Okay, so notes, let me go down to display the outputs. Here, month, first name, and last name. So notes, this is still lazily evaluated. Nothing much has actually happened until display asks for rows. Spark builds a plan and only executes when you ask for output, which is why it can optimize across all of these steps at once. Let's add one more code cell and let's run it. So here we are writing the result back into the lakehouse, transformed df, write mode, override, Parquet, files, transformed data slash orders. Let's run it. Parquet stores data by column instead of by row. It compresses well and it carries its own schema. If you read one Parquet file in 6 months, it still knows what its columns are called and what type they are. A CSV never does. Note, mode override. Run these cells twice and you replace the output rather than doubling it. The alternative append is the one that quietly duplicates your data if you are not paying attention. So let's do something. In the Explorer pane, instead of files, ellipsis, and say refresh. So then open transform data. And after refreshing the files node, there is our folder order. Note it's a folder containing one or more files. So not a single file there is. And Spark writes in parallel, so each worker writes its own part. It is normal and you should not try to fight it. So let's add a code sale and run it. Let me make it smaller. Let me select files, orders. And here I'm adding new code. And this is my code. So, and run. So reading it back is the same shape of code is reading the CSV, except we do not need a schema. Parquet brought its own, right? Let's add one more code cell and run the following code. So orders, df, data frame, write, partition by, year month, mode override, parquet, mode, parquet, and print. Okay, transform data saved. So transform data saved. So let's refresh files here. Okay. And we can see this partial data. Let's expand it and look at the folder names. Here equals 2019, 2020, 2021. And let's click on this. And inside, we see the other folders like month equals 1, 10, 11, 12, 2, 3, 4, 5, 6, 7, 8, and 9. Spark has written the partial values into the folder structure itself. This is not cosmetic. When you later ask for 2021 only, right, or 2020 only, the engine can skip entire folders without opening a single file. That's called partial running. And a large data set is the difference between a query that takes seconds and one that takes minutes. Let's add a new code cell and run the following code. Let's go back to our files, orders, and new code. At Control V, and let's run it. So 2021 only, right? And here is the detail people miss. Year and month are not columns in the result. They were in the path, so they were not written into the files. If you need them back as columns, you load from the parent folder and Spark infers them. One warning before we move on. Partitioning is not free. Partition by something with a few dozen values like year and month. Do not partition by customer ID, or you will create 100,000 tiny files and make everything slower. That's the small files problem, and it's the most common way people hurt themselves with this feature. Let's add a code cell, and run it. Same data frame, different destination. Instead of writing files into the files area, save as table registers table in the tables area. The format is delta, which is Parquet plus a transaction log. So The description tells you where the table actually lives in one lake and what provides it users. Worth reading once, so you believe that the table here really is just files with structure over them. Okay. And here, the transaction just log is what gives you database behavior on top of a data lake. Transactions, raw versioning, the ability to look at the table as it was yesterday. It's the technology that makes the word lakehouse mean something rather than being a slogan. Okay, let's refresh the tables node in the Explorer and expand it to show sales orders. Ellipsis and refresh. Let's expand TBO and sales orders. Okay, so here we can do the following. So on ellipsis, I'm saying load data, and this is the new code, like this one I'm getting. And this is my lakehouse sales order underscore LH, let's say, run. So there is SQL. I'm sorry. There is SQL embedded inside Python, returning a data frame. That's often exactly what you want. Query the language that suits the question. Then carry on in Python. Let's add a code cell and run it. Just pay attention. We are doing our codes while tables is selected. And if you would rather not wrap SQL in Python at all, use a magic 2% SQL science. And the word SQL, so this one, at the top of the cell, and the whole cell is now Spark SQL. No quotes, no escaping, syntax highlighting, and the results render underneath automatically. Let's run it. And this matters for teams. The analyst who thinks in SQL and the engineer who thinks in Python can work in the same notebook on the same data without either of them having to convert. That's worth saying out loud in your organization. Let's add one more code here and run. So what we are going to do, I'm going to select new chart. Okay. And then I'm selecting build of my own. So my chart type is going to be bar chart. I can give my title like sales orders. Okay, I'm leaving subtitle. And for X axis, I'm going to select item. And for Y axis, I'm going to select quantity. Series group It's going to be none, nothing. Aggregation is going to be sum. Missing and null values is going to be displayed as 0. And this is what I'm getting. So 0 code, and we have a chart. This built-in view is for orientation, the quick look you take before you decide what's worth investigating. It's not designed for anything complex, and it's not what you would put in front of a board. For that, you either build a Power BI report over this lakehouse, or you use a Python plotting library, which is what we will do now. So let's add a code cell and run it. Here, first we aggregate down to 3 rows, one per year with revenue and count, yearly counts. I mean, order counts. Always aggregate in Spark before you plot. Never pull a million rows to the driver to draw 3 bars. Let's go bottom, and we'll see this one. Let's add one more code cell, and let's run it. So one line, let's go to here, deserves attention to pandas, this one. Matplotlib cannot read a Spark data frame, so we convert. That conversion pulls the data onto a single machine, which is completely fine for 3 rows, and a genuinely bad idea for 3 million. Aggregate first, convert second. Default chart is usable and completely unlabeled. Let's fix that. So this one, right? Let's modify, or let's add one code cell and run it. Control V and run. Okay, let's go bottom, and we see this one. Labels, like here, and revenue by year, the title name, and revenue. That we didn't see here. Okay. So title, access labels, a color, horizontal grid lines, rotated ticks, nothing clever. But the difference between a chart nobody can interpret and one that explains itself. So let's pay attention here. plt.clf. This clears the previous figure, explain it. Since viewers who omit it get plots stacking on top of each other and assume something is broken. That CLF at the top clears the plot area. If you leave it out and rerun, matplotlib keeps drawing onto the same figure and you get a mess. It's the first thing to check when your chart looks wrong. So let's add one more code cell and run it. Okay. Okay. Control C. and Control V, and let's run it. Every plot lives inside a figure. Until now, the figure was created for us invisibly. Here we created deliberately and set its size, which is how you control the shape of the output rather than accepting whatever you are given. So let's add subplots and run. So here, I'm going to add a new code, Control V, and like this. So one figure, two axes, two different chart types, side by side, with a title over the whole thing. X0 is the left, and X1 is the right. And once you understand figure and axis, the rest of matplotlib is just looking up function names. So let's do something related to Seaborn. For this purpose, I'm going to add a code cell and run them. So let's go button. And here, I'm going to add a code, Control V, and run. So let's go button. So actually, same chart, one line of plotting code, cburn, is built on top of matplotlib and hides most of the ceremony. You name the data frame, the X column and the Y column, and it works out the rest. Let's set a theme and run it. And run. Ah, okay. There is invalid character, it says. So let me copy and paste my code once again. I hope it's clean. So maybe this is due to this one. So let me do it this one. I hope, yeah, the problem was with the code. I think it's going to work now. Yes. Import, yeah, and run. Yeah, it works now. So one line sets a theme across every chart that follows. If your organization cares about consistency, that's how you get it without styling each plot by hand, right? So set theme, style white grid. And I'm going to make some changes, like changing this chart into the line one. So for this purpose, I'm going to add a new code, let's say code, and Control V. Here, create a line chart, SNS Cburn line plot, and run it. change one word, bar plot to line plot. So here was bar plot, we changed it to line plot. And the chart type changes. That's the trade you are making. Matplotlib gives you total control at the cost of verbosity. Seaborn gives you speed and sensible defaults at the cost of some control. Use both for different jobs. So let's stop session. So it's enough to click here and session stopped successfully. Do this at the end of every working session. The Spark session holds capacity while it's alive, and on a shared capacity, your colleagues will not. So let's select a workspace, and let's select this one, DP sales orders. Actually, let's go back, and from here, ellipsis, workspace settings, right? Okay. And we are going to remove this workspace. So let's go bottom and say remove this workspace, delete. And because this was a demo, I deleted the whole workspace. Everything goes with it, the lakehouse, the files, the notebook, the table. And if you are following along on a trial, do the same and your capacity stays clean. So I'm going to stop sharing my screen, right? So let's just look at back uh, just what happened in the last hour. Sorry. We create a workspace and a lakehouse. We uploaded three CSV files with no headers, and we hit that head on. We defined the schema. So the data had proper names and proper types. One wildcard turned one file into three. Then we filtered. We counted distinct customers. We grouped by product and by year. We derived new columns, split a name into two fields, and reordered the output. We save it to Parquet, then partitioned by year and month, and watched the folder structure appear. We registered the delta table and queried it with plain SQL. We drew charts three different ways. Every one of those steps was a handful of lines, and none of them changed when the data got bigger. That's the point of Spark. Three things to do next. Repeat this lab yourself. The link is in the chart, and then try it with your own files. Because the moment it works on your data is the moment it becomes real. And if you want the formal path, this material maps directly onto DP600 exam objectives. I will stay for a while for questions. While you are typing, one favor, tell me which part you would like to go deeper on, because that decides what I record next. Actually, yeah. And thank you for spending the time with me. Everything is in the description. The replay stays up, and I will see you in the next session.